Here we are yet again for another Friday night with the Astronomical Society of Southeast Texas. We're going to do an online astronomy meeting because 2020 is bleeding over into 2021, as I suspected it might. But we're going to have a good night of chatting about astronomy and hanging out. And so feel free to, even if you're not a member of our astronomy club here in Beaumont, you're more than welcome to join us. We're so happy to have y'all. If y'all want to drop where y'all are watching from in the comments, I'll be throwing those up tonight as well. We got Justin in from Louisiana. JC is here. Jackie, I'm sorry. I know Jackie, old friend of my family. Good to see you, Jackie. Carl's Cosmos hanging out with us for another asset meeting, which is very awesome. It's good to see you, brother. And Evan and Aaron, good to see y'all. We are the Astronomical Society of Southeast Texas. We are a nonprofit 501c3. If you want to donate to us, we'll take it. We are based here in Beaumont, Texas, and we have a great membership. The members of our club are fantastic people, fantastic astronomers. It's a great organization to be a part of, and I've been the president for, this is my 10th year. Actually, 2021 is 10 years, which is an insane number. But I've loved every second of it, and it's still a great time. And so we're gonna talk some astronomy. We're going to hang out with y'all. If y'all have astronomy questions, we might be able to answer them. Who knows? Eddie knows more about the sun than the sun itself. So we're going to talk about that later. That's why he's hanging out underneath it. And we've got his beautiful wife, Kat, here with us as well. So it's good to see Eddie and Kat here. They are indeed the treasurers for the Astronomical Society of Southeast Texas. So we'll be getting updates from them on how much money we have to go to Fiji later. And but I want to get through some of these comments real quick since everybody's hanging out with us, telling us where they're from. It's good to see all you guys here. George, good to see you, buddy. Brandy from Connecticut. Steve Muncie. Good to see you, Steve. Long time no see, brother. And we got a lot of cool topics to talk about tonight. Actually, some really fun stuff. Some stuff you may have heard about and some stuff you definitely probably haven't heard about. So it's going to be a lot of fun. And again, Eddie's got a solar report for us coming up, and so we're just going to get to the meeting here because there's no way I'd be able to catch up with all these comments, and I apologize for not being able to get to all of them right now. But if we don't get started, it's just going to be me talking and y'all seeing random comments for a while. But we got a lot of people from Southeast Texas here. Joy looks like from Beaumont, Texas. TJ's in Oklahoma. Our Nestina is in Netherlands. So we got a lot of ultra local people here with us. Zach from Fort Worth Astronomical Society. Good to have you, Fort Worth. That's awesome. So yeah, I'm Will. I'm the president of the Astronomical Society, and we're gonna be hanging out with you along with my friends Eddie and Kat over here. Again, they are the treasurers of our club. And what I want to do, I guess, is I'll put up this screen here. And I'll put us over to the side here, and we'll just get started. We'll get going in this, because I call this meeting adjourned, I guess, as it were.
You call it to order. You call it to order, Will.
Oh yeah, adjourned, I guess, is where you leave. See, I don't even know how to do this. After 10 years, I have no idea how to run a meeting officially, which is how laid back of an astronomy club we really are. And that's one of the best things about the club, honestly, is how laid back and fun we are. But one thing I want to get right off the top here out of the way, January 11th, 2021, right after sunset. If you have a good western horizon, this is what you're going to see. Jupiter is on top there. You've got Mercury off to the left, that little reddish, pinkish one off to the left. And you got Saturn down below. Now, we just had the conjunction between Jupiter and Saturn, which was amazing. We're going to talk a lot about that. But now we got a triple conjunction, which is really cool. And Eddie, I know you're planning to get out and see this, right?
Oh, definitely. Yeah, I'll be out there. I think we can probably see that from our balcony up here on the 3rd floor of our apartment. I'll set up my little 80 millimeter. It's where I saw the great conjunction from there. So this will be in a similar location. Yeah,
awesome. Yeah, exactly. Like Eddie said, if you saw the great conjunction, you're going to want to look in a similar area, maybe a little lower in the horizon. And Mercury is going to be fairly tough to see. I've seen it, naked eye myself. It's very tough. But Jupiter and Saturn are easy. I hope some of y'all got to see that as well. But if you didn't, we got some pictures to show y'all about it. But again, January 11th, right after sunset, You're going to want to be out there right as the sun goes down, because this is going to happen quick and it's going to set fast. It's going to set maybe less than an hour, Eddie, after the sun goes down, maybe about an hour, if that.
It'll be less than an hour. It was less than an hour for the Great Conjunction with just Jupiter and Saturn. I mean, you could see Jupiter before the sun actually dipped below the horizon if you looked. But once it got dark, it's less than an hour.
Yeah.
So,
but it's going to be a fun one. It's a great photo opportunity for those of y'all that are playing with photography. Once it gets just a little bit dark, this will be a great exposure to take. And just all you need is a good western horizon, like Eddie said. Get out and give it a go. That's y'all's homework, I guess, right off the top. There's your homework for January 11th if you have clear skies. But if you don't have clear skies, I'm going to need a 1,000-word paper on why the Grand Conjunction is cool. So just let y'all know.
You know, it's always helpful to write it down on a calendar or set an electronic alarm on your phone or something to remind you, because our lives get so busy and we get so focused on doing other things. I've had events like this come up and I suddenly realized that, oh my gosh, that was last night and I missed it.
Yeah.
So definitely have some way to remind yourself.
Absolutely. Good. It's a good call, Eddie. A little calendar app notification is a great idea for that, for sure. So don't miss it or you'll miss it. And speaking of that, observing reports, put them in and we'll get to y'all's as I see them come in while we're doing this. And why don't we do that, Eddie? I know you've been out observing a little bit. Why don't you at least tell us a little bit about if you've been out observing or if you haven't been? I mean, I don't know. I guess you have been. I hope you have been.
Yeah. Actually, I started with Jupiter right before the conjunction, and I watched Saturn get closer and closer. And every evening I was out there with binoculars, seeing how early I could see it. You know, I was very careful not to look towards the sun, but I was able to see Jupiter naked eye about 5:45, and then Saturn would brighten up about 15 minutes after that, 20 minutes. So about 6:15, they were both in good view. I had my telescope out there and I messed around trying to take pictures throughout the days as they got closer and closer. And I got some, okay pics, about as good as you're going to get on an iPhone through an eyepiece. But it was exciting and I was able to show people, and I told everybody that I could think of. And after the conjunction, after they started drifting farther apart, we had an opportunity to show other people through a new Christmas telescope. And I'll bet Kat wants to talk a little bit about that.
Yeah, so a rare thing, Kat, someone actually had a telescope in stock for someone to get for Christmas. That's nuts, especially in these times.
Yeah, our son wanted to get, our 9-year-old grandson wanted a telescope for Christmas. And he did not listen to our advice and ordered one from Costco, and much to our dismay. But it actually ended up being a really good scope for a 9-year-old. It was the Astromaster from Celestron, and it's on an okay tripod, but it was easy for him to push around. It had a good
finder, a red dot finder.
Yeah, red dot finder. And so our grandson's name is Jonas. So he was able to pretty quickly use the red dot finder. And we brought it out into the street, easy to bring in and out of the house, which to me is important. So my son Jeremy would bring it out twice during the holiday weekend. We brought it outside, kids in the street, adults in the street, all came out, looked at it. Even our grandkids from another neighborhood came over. We tried to socially distance, disclaimer for COVID. And we showed it to a lot of people. So it was really cool. So that Christmas present got a good use over the holidays and really kind of sparked a 9-year-old's interest into astronomy with that great conjunction to be able to see, or separation of.
And like, again, how rare is that there was one in stock and then it arrived and there were clear skies and then minds were blown, right?
Yeah. And they got to see something, and they probably don't realize the special event that they got to see, but maybe in future years as they try to see that thing again, they'll realize, hey, this is not going to happen for quite a long time, maybe not even in my lifetime for some of the older adults. And we got to do a little bit of outreach and talk about the difference between planets and stars and the solar system, and how it was just an optical alignment. And it was fun. It sure made me miss the times that we've been able to do that on a larger scale. Definitely.
Yeah, those days are coming back, and it has been I don't know what's the word, kind of frustrating, to want to go out and do some outreach and not be able to. But you know what? I hope that when outreach does come back, it will be even bigger than before. More people will want it. We will want to give outreach back to the community more, I think. And so I think it'll be, like all things, there's an ebb and flow. There's a tide goes in and tide goes out, and nobody can explain that. So I'm so glad that you guys did get to see it, especially with a scope, which is awesome.
Yeah. Hopefully, because of COVID and everybody socially distanced and kind of had to internalize, that more people started getting equipment, even if it's just binoculars, and kind of started studying themselves and looking up, so that when we can get together, they know a little bit more about astronomy and equipment, and we get together and we're a more knowledgeable group as a total and can reach out to the community better.
Yeah.
That's right. Yep. You always learn, even at outreach events. To this day, I've done, dozens and dozens of them. I still learn something, because somebody will ask me a question that forces me to figure something out or to explain something a different way. You know what I mean? So there's always opportunities to learn, even if you think you know it all or you've been around the block more than a few times at a star party. There's still way more for you to learn out there. And that's why we get together as an astronomy club, and that's why we hang out. And just like you said, that's why we do what we do, which is always it's always needed, I think, especially like these days. And so once we all get back to normal, it'd be really nice. So yeah, if any of y'all out there have any observing reports, we'd love to hear about them. I know there's been clouds and snow and rain and all this other stuff, but that's observing, I guess. If it's just observing a storm, unfortunately.
Yeah.
But that's you're observing a storm on the side of a planet. You just so happen to be under the storm, but hopefully y'all been at least observing that out there if y'all have been. But I wanted to go through a couple of the things that have been put on the Astronomical Society's Facebook page over the past several weeks that just kind of are on a tab that nobody really clicks on when they go to our page, but it's the community tab. And June Moore is a local astronomy aficionado, or I guess, or an astronomy enthusiast, I guess is the better word. June took this picture. She said, "I'm new to the group, interested mostly in landscape astrophotography. New at that also. Just took this on the 6th of October on the Sabine River, which is just it runs right through the edge of Texas here. And so it's a great shot. And I figured I'd give June a shout out during the observing report section and show one of her lovely shots. I mean, it's really cool to see the river like that with the Milky Way.
That is a beautiful picture. That's well done.
Yeah. Can see a lot of the old favorite constellations buried in there, and like Sagittarius, I see it kind of in there. Scorpio's right at the bottom, right above the trees. It's very nice.
It almost looks like smoke rising from a fire out of the tree line.
Yeah, you're right, Eddie.
It's a very interesting composition.
It's the Smoky Way, not the Milky Way anymore. And then another friend of ours who joined the club fairly recently, about a year or two ago now. It seems like time is flying pretty fast. But Adam Corville was out doing some observing, and this just goes to show right here that you don't need expensive cameras or all this stuff to do amazing stuff and share it online. You see, he wrote down this stuff for his own log. He's logging Jupiter and Saturn as they're coming. He's got time and date on there. He's got the IPCUs, the telescope, the Orion Starblast 6-inch Dobsonian. And he says that he got both of them in the same field of view, which good luck doing that again until 2080, because it ain't going to happen. Unless you're just looking naked eye, and then you'll have them in the same field of view, but not in the telescope. If you missed it, you missed it. But Adam didn't. And so I thought I'd throw up some of his sketches, because he didn't just stop there. He went on to the Orion Nebula, as you can see over here on the left. And Gave it a nice sketch. Looked pretty accurate to me. And I've seen that nebula hundreds of times, and I can look at that drawing and tell you exactly what it was straight away.
Yeah. I think it's great. He's one of our newer members, and he's just really immersed himself.
Yeah, absolutely.
Really putting out a lot of effort there.
Yeah, this is not, this shows initiative that he, has the drive to do astronomy. And again, you don't need cameras and all this expensive, tech to do astronomy. You need your eyes, maybe a pair of binoculars, maybe a telescope. The more you add to your arsenal of how you're going to collect photons, the more ways you'll be able to do it. And so, you can see here, he's got both of them here again. They look exactly like I've seen them. I mean, the drawings are spot on. And so he's really got a good hand at drawing. So he's going to love these the Astronomical League Awards that are coming as he gets further into the hobby, where you do have to do a few sketches and things like this. But he did Orion Naked Eye and a wide angle of the moon, which is really cool. And I think he says, I don't think he gave a date on that, but I'm sure he could tell us the date in the comments. But I just thought I'd throw some of those up there. He posted those on the Astronomical Society's Facebook page, which is really cool. And if y'all want y'all's featured, throw them up there. I'll go through those before every meeting. And if you have something you want to share that you've taken a picture or you've done a drawing, let us know. I'll share that stuff, no problem. And Howard also loves to share that kind of stuff in the newsletter. And Howard wishes he could be here tonight, but he had prior obligations. But this is an image that I took, and it looks an awful lot like Adam's drawing over here. It's just reversed. Yeah. Obviously, we're using a different, but I put this in here because I think he nailed it. I think it was the exact same night that he was looking at the moon that I took this image. And one thing I wanted to kind of point out, I can't see my cursor here, but on this bottom left-hand side where there's these two sort of light islands where sunlight is coming through craters basically, or, basically shining off the front surface, or the lit surface, I should say, and coming to us just on the edge of the moon there. I don't know if y'all can kind of see that, but there's two little light sources on the limb of the moon. Super cool. I've only seen that kind of thing a few times, and it depends on the wobble of the moon if you can get a chance to see those kind of things. But you never know what you're going to see when you look at the moon at night to night. It always changes, because more and more of it is becoming illuminated as the days go by until you get to full moon, and then less and less of it is illuminated. Yeah. The moon was beautiful during this whole conjunction thing, and Eddie, I know you were out observing the conjunction too. Now you're in Killeen, so the weather was pretty good over there, right?
It was excellent. The day of the conjunction, we had clouds roll in, and I just got a sick feeling. But right around sunset, it started clearing up, and I was able to catch the conjunction through some holes in the cloud. And actually, some very thin cloud layer helped me resolve images a little better. It wasn't so bright and glary. So I was able to see.
Yeah, and this is video that I took of the night of,
That's the night of, yeah.
Yeah, and this is just on my iPhone, just in the back of my ED 102 from Explorer Scientific. And I can tell you that in the eyepiece, I was like, wow, but I didn't really get a chance to enjoy it much because as soon as I got an image, I was like ready to start taking video and everything. And so you see me just playing with settings and seeing if I can get detail out of Jupiter or Saturn. And it's hard with an iPhone. Most of y'all know this, that have tried to take a picture of the moon or Saturn with an iPhone or Jupiter. It's tough.
It's hard also, Will, if you're manually guiding your scope, because if you lose it in the phone, you got to pull the phone off to recapture it in your scope, and you can track it once everything's together, but it's a challenge.
Yeah, it's not easy. Having a tracking mount is something that I take for granted for sure. And when I'm not using that, when I'm using one of my other scopes that doesn't track, I'm like, oh, this is horrible. But, this was, I think, on the 20, I'm pretty sure it was the 21st this night.
This is the conjunction because one of the moons of Jupiter is right in front of Jupiter. It's traversing.
Yeah,
you wrote Jupiter. So you lost it there.
Yeah.
It's lost in the glare.
Yeah, and I was trying to pull stuff like that out, but again, iPhone, not the best, guys. I had similar conditions to Eddie here in Southeast Texas, just high thin clouds, and again, that actually served to help. I did a live stream on Facebook on my Deep Sky Dude Facebook, and I almost hit 10,000 live viewers, concurrent viewers, which was insane. Absolutely insane. And that video sits at like 557,000 views right now, which is nuts. Because I never bought a Facebook ad ever, and I never will. Ha ha ha, Mark Zuckerberg. I couldn't believe how, because people were just sharing it and everybody wanted to see it, and most people were cloudy, so it just kind of a perfect storm. But to those of y'all that shared my feed that night, thank y'all so much, because it was amazing. What I want to do at the end of the meeting, I'm going to bring up some more images of the conjunction in the newsletter, because I'm gonna actually leave the session to go to that in a minute. But right now, what I want to talk about is dues. Dues are due for the Astronomical Society of Southeast Texas. If you want to be a dues paying member to get all the benefits you see below there, it's $30 for your whole family, which is a fantastic deal. I don't think you'll find a better deal anywhere else. And it includes, again, you get all the benefits and perks listed below. And you can just watch our online meetings and not be a member. It doesn't matter. But if you want to be, included in the group, if you want to be a part of an actual scientific community who's doing fun research and having a blast doing astronomy, we're a cool, fun group to be a part of. And so you can actually pay your dues through our website, which is asset-astronomer.org. And you can pay your dues through the PayPal. And Eddie and Kat will get that, and they'll mark you down in the book, and you'll be all official. And you can say you're part of a astronomical society, which is pretty cool, I must say. I joined the club in 2009, and I never regretted it. So, and I know Eddie and Kat haven't regretted it. They're still here. So you can't really, people like us, we love astronomy, and so we do enjoy the social aspect of it too. Quickly, before the treasurer report, we do have an Amazon Smile. If you shop on Amazon and you want to give us Jeff Bezos's money, all you have to do is go to smile.amazon.com, put in that EIN at the bottom, or just search the Astronomical Society of Southeast Texas, like you'll see it at the bottom left there. Once you're supporting us, anything you buy, we get 0.5% of that money. It goes into our fund, and then Amazon pays us out. And we've gotten a lot of free money from Jeff, from our members and other people purchasing things on Amazon. So thank y'all if y'all purchased anything through there. Hey, we haven't gotten an update on that anytime soon. Have we, Eddie, or did we have an update on that?
The last Amazon Smile donation that we received was, month before last. So right before or right after our last meeting, we got a donation, and I'm sorry you've caught me flat-footed. I think it was about $75. It was the third quarter donation. So we get the donation about a month after the quarter ends, and we've gotten our third quarter donation for 2020. And it was free money from Jeff Bezos.
Yeah. And nothing is wrong with that. I mean, absolutely nothing. We all like free money. And Jeff is giving money out to nonprofits. I think that's great. And so if you do shop on Amazon and you got to get that new telescope or whatever it is you're going to go buy, if you want to support us on that, we would really appreciate that, because that will help us out tremendously once COVID goes away and we get back to a little bit of normalcy here. So with that, I will turn it over to Eddie to tell us that we're not in debt as a club, which is great.
We're not in debt as a club, and that is great. Our balance has remained constant since the last meeting. We've had, I think, 5 people rejoin for 2021, and that money sits in the PayPal account until I transfer it over. So that's why our bank balance hasn't changed since last month. The dues, they are due again for members that want to remain members or new members that want to join for 2021. And you can find the information on the webpage. There's a PayPal link on our asset webpage. And if you have any trouble with it, just email me and I'll be happy to get it to you. Or I'm going to send out an email to all our current members reminding them that dues are due, and to give them links to different ways they can pay their dues. They can either write a check and send it to our P.O. box in Groves, Texas. That's the way we all started doing it before this electronic novelty became a habit for us. Now we can do it with PayPal online, and I'll have to say that's a lot easier for me, and it's quick and easy for the person doing it. It does cost $1 extra to use PayPal because PayPal wants to get their cut of it. So if you're going to mail it, you got to buy a 50-something cent stamp. So it's just a few cents more to do the PayPal. If you're thinking about joining as a new member, there is a form on our website account that lets you give us your information, your name, your email address, a phone number, your home address for any mailings that we might have. And it will allow me with that information to register new members with the Astronomical League so that they'll be eligible to do programs with the league. And that's about it.
Which is a great perk. It really is. Those. Oh, go ahead, Scout. Sorry.
Sorry, Jay was asking what the site was again. It's scrolling right across the bottom of the screen. Just kind of look right across the bottom.
Yeah. www.asset-astronomer.org.
And it has a little button, PayPal. Just hit it, and it'll take you right to it.
And Brandy says, what if you're not in Texas? Hey, it doesn't matter. We have all kinds of people who join our club these days, which is awesome.
Yeah.
You know, you're not required to do anything other than pay your dues to be a member. That's it. Then we do all the work for you. We send you the newsletter. We send you, a club email when we're going to be live and things like that. That's really it. So
you get the magazine.
Yes. And you get the Reflector quarterly, which is amazing. So you get 4 a year, I guess. Is that right? Or that's at 3?
Mm-hmm.
Yeah, it's 4 a year. It's every quarter.
Yeah, I guess that makes sense. Quarter, right? But yeah, and it's a great little magazine. If you do one of these Astronomical League awards, like Eddie was talking about, and you complete it and send your stuff in, they put your name in the back of the magazine. It's pretty cool. It's pretty cool to see your name. Yeah, you're a published astronomer.
You're somebody.
You're somebody and not nobody, and that's exactly what it is. So yeah, we'd love to have y'all join. If y'all want to join a little club here in Southeast Texas, we would love to have it. And so what I'm going to do is, let me go back to my other screen here. So many screens. What I'll do is we have a little chunk of news from Brenda, a good member of ours, been a long-time member of the Astronomical Society of Southeast Texas. And she said, she brought this story to my attention and through the newsletter. Never saw this. This was something that I had no idea of. But she says the new observations by the National Astronomical Observatory of Japan suggest that our planet is located about 2,000 years closer to the Milky Way center than previously thought. And just as in our solar system, where planets closer to the sun move faster than those further out, our Earth and sun are now seen as moving about 4 miles per second faster than we thought we knew. Which is 4 miles a second is ridiculous.
Yeah.
And to think that we're moving that much faster than they thought we were is pretty ridiculous. But she says the new work suggests our solar system is located 25,800 light years from Sagittarius A, which I've always known about 24. So yeah, we're adding a little bit extra, I guess, right? And then which is she calls Sagittarius A star, the region of the Milky Way center where the black hole is. And new estimates are the result of an improved model of the Milky Way based on recent observations. Fascinating stuff. So thank you, Brenda. But Brenda always does she always does our news segments when we have the in-person meetings. And so I can't wait to get back to in-person meetings so we can hear Brenda do all those awesome news stories again. Those are always fun.
Yeah.
And Howard had one that I thought was really cool. Something to always look for in the winter time. The winter circle is out, and you can see there he's drawn it for you. So it starts off at Capella, goes through Castor and Pollux, works its way over to Procyon, Sirius, goes down to Rigel, up through Aldebaran, and basically encompasses all the fun stuff in the winter, which is the Orion area, the Gemini, the Riga areas. Lots of fun open clusters and a few nebula in there to look at. Some planetary nebulas too. Some fun stuff. Lots of open clusters. Too many open clusters in that area to even talk about. I don't even want to look at any of those open clusters ever again. There was so many right behind Canis Major off to the left where Monoceros is. And I mean, literally like 60 open clusters or something like that is what I had to do to get through the Herschel 400. And I'm just like, and they're right next to each other. So you're just like one after the other, sparse grouping of stars. But it gives you a sense of wonder of how William Herschel, could tell that these objects were associated with each other. It's fascinating. Right. It's just so fascinating.
Some open clusters are easy to pick out because it's a grouping of stars and there's nothing around them. And it's very obvious. It's like, that's the open cluster. And so it's easy to map it with whatever mapping utility you're using. But some clusters are buried in a bunch of other stars, and you got to kind of know what you're doing. You got to be able to star hop to it and pick it out and then recognize it. It's a lot harder in a starry sky than it is in a sparse or a void sky.
Yeah, no, that's 100% true. And that area right there to the left of Orion on the back of Canis Major going down that way is the Milky Way band, just the other side of it, looking away from the galactic core, Sagittarius A star, right? So we're looking away from the galaxy core. And, it's like Eddie said, good luck. I mean, some of those I had to actually look up images of them and then where they were demarcated to know where the open cluster ended and the rest of the expanse of stars continue or started. It was really kind of confusing, but then after a while you get the hang of it. After about 30, you're like, all right, this is just the status quo here. We're just gonna look at another grouping of stars. Okay, here we go. And but yeah, it was a fun thing. And that, the winter circle, well, it's here every winter. Good luck looking for this in the summertime. Just saying. Well, actually it's kind of setting in the summertime. But so or I guess spring and into summer, then you won't see it at all. But it's a good thing. And these are parts of the newsletter that if you're a member, you get the whole newsletter as well. Which
as far as that winter circle goes, that's a good way to learn the sky. I mean, you're learning six major stars that are in this circle. And they're very bright. They're very easy to pick out. Once you learn those six stars, you'll learn the constellations they're associated with. So it's a good way to learn the winter sky.
That's a great point, Eddie. That's something I always, gloss over that because I'm down the road a little ways. I forget to even bring it down to that sort of basic level. But yeah, that's absolutely true. And like Eddie was saying, if you learn these star names, they never change, y'all. They never move in the sky. I mean, they are moving in the sky, but we don't live long enough to notice that movement. But learn them, and guess what? You don't have to learn them ever again, unless you're trying to remember what was the name of that weird sea Capella, whatever. Trying to remember the name sometimes, or then trying to like pronounce these things sometimes. When you get to like Zubanel Shamali, like what?
You'll never forget that one, Will.
Yeah, no, because it took me like a day and a half to figure out how to pronounce it, and then I think I'm still even saying it wrong. So, but yeah, like Eddie said, learn the constellations first. And then learn these star names, or do them at the same time. At least learn a couple of star names in those constellations. That'll help you insanely. I can't even tell you how much that's going to help you as an observer. If you know the constellations and you know some star names, I'm telling you, it's going to be life-changing for you.
And as you progress, you'll learn more things about the star names that you learn. Like Sirius, one of the prominent stars in the winter sky, is the brightest star in the sky. It's not brighter than Venus. And somebody's asked me, well, what about Venus? Well, Venus is not a star. It's a planet. It doesn't give off its own light. It reflects sunlight back to us. But Sirius, the alpha star in Canis Major, is a star like our sun. And it's far away. and we can still see it because it's that bright.
Yeah. And it's, it's one of the closer stars too. I mean, Sirius is 8.5 light years away, I think. And a star like Betelgeuse there in the middle, I think is 600 light years away.
Yeah.
And so if you kind of learn those things as well as learning the names and some of that, you'll kind of almost get a perspective of how this stuff is laid out in the sky. And it'll kind of give you an overall look at how this stuff kind of works. It's really powerful stuff.
And you don't have to learn it all at once.
That's right.
Learn 6 star names and start with one. Start with Sirius. Learn that one. Go out and figure it out where it's at in the sky.
Yep. Be able to call it out like whenever you look in the sky, like Sirius, boom, and then learn something in Orion, like Alnitak, or one of the belt stars. All the belt stars always stay the same, so you can always get those whenever you need them. It's good advice. But this is another perk of the calendar. You get the newsletter, you get the calendar. And Howard really did a good job on this one. He put all kinds of fun stuff on this one. So, and I won't read all of it, but the really thing that's useful to me as an astronomer is knowing when and where the moon will be. So you can see that, new moon is coming up on the 13th. And so we're basically almost to new moon now. And then we'll get the full moon on the 28th, which is, it is what it is. We get the full moon, so we got to deal with it sometimes. But the moon is beautiful. I shouldn't talk bad about it, but and I won't talk bad about it. But I will talk bad about 2020 and how it's spilling over into 2021. The next star party that would happen would be the winter star party down in the Florida Keys. Again, I talked about this last meeting, and it is still canceled. But there's always 2022 for a winter star party. And, we might see some of the spring, summer, and fall star parties going on with restrictions, despite the virus and everything. But winter star party is canceled for 2021. But the Texas Star Party 2021 is moving forward with way tighter restrictions. There's going to be no talks. Food is going to be done like on a to-go type thing, from what I understand. They're still working out all the details of this, and they're still waiting really to see if it's going to be a go. But as of now, May 2nd through the 9th, 2021 will be the Texas Star Party. You can see the website there. Beautiful picture by Alan Dyer here of the upper field of the Prude Ranch Texas Star Party. And this is one of the premier star parties, and it's one of my favorite. It's a great event. You'll meet so many cool characters there and so many cool people. And it's just a really wonderful thing to be a part of. And it will change your outlook on astronomy when you see a sky as dark as the Davis Mountains out there. Eddie and Kat have been to Texas Star Parties in the past. And typically Eddie and I do them together. They put our camper spots near each other. So we end up walking to the field together and doing all that, which is fun. But I'm excited. I know again, there's going to be some restrictions, but I think we can handle that. I think the El Dorado Star Party proved that people can assemble in smaller groups than previous and do it just fine. I don't think I heard of anybody getting sick from the El Dorado Star Party. Have y'all?
I did not. No. But,
yeah.
No one came forward and said, "Hey, I traced back to you guys, and that's where I got sick." But
and
we had one incident, and it was one of our astronomer friends took a spill. He actually fell, and he injured his arm and wrist, and he's doing better now. But
he's in the crowd too.
Yeah, he's here, Spencer.
He tried to fight Mother Earth, he tried to punch her and he lost the battle. That's how that goes. Gravity will always win the fight, unfortunately.
Yeah, you can do the experiments with gravity all you want. The outcome's always the same.
Yeah, the ground is always going to win. When you're talking about something as massive as the Earth, it's going to pull you toward it, which is if you think about falling that way, it almost seems kind of comforting, except for the sudden stop at the end. The Earth is just trying to pull you in. So Texas Star Party, I hope to see some of y'all there. If y'all don't go, that I'm going to make a video about it. So if you need to skip for pre-existing conditions, you're over 65, you need to go to the Texas Star Party website and look at their criteria that they have. If you fit any of that, you might not want to go. You might just want to stay away this year and then go in 2022 and watch the video, and you'll at least feel like you were there in part, I hope. So that is something that is coming up. But now, something I'm excited to talk about, Eddie, is our closest star is coming out of her nap or slumber. I mean, it's not really a nap, is it? It's like she's been asleep for 12 hours, it seems like, almost.
Yeah.
But
it's a very predictable cycle. We've been following the cycle for years and years, and we're coming out of what's called a solar minimum, and it's a slow start, but we're getting there.
So do you want to, let's see, I'll stop sharing mine here. There we go. Oh, I see that Howard Miner is here. There he is. Howard, we miss you. We wish you were here.
Hey, Howard.
We'll hopefully get to have you on next, I almost said next week, but next month. Hopefully we'll get to have you here with us. And let's see.
I shared the wrong screen.
Oh, okay.
Here we go.
There it is. So Eddie's going to tell us what's been up with the sun, which I can't wait to hear this. So Eddie, take her away.
Well, Will, can you see my cursor?
Yeah, I can.
Okay, excellent. So I'll use it as a pointer. So as I was talking earlier, the solar cycle is a very predictable cycle. It's 11 years in duration. It was the one before last, and this was our last solar cycle. And as Will said, it's been very quiet. We've been in a solar minimum down here, but we're coming up, and we're predicted to be at solar maximum in July of 2025. I say that every month, and I'm looking forward to it, but we've had some good solar activity, some very interesting stuff happening. Let me see if I can. There you go. So I made this little calendar up, and it's something I like to do to kind of give an idea of how active the sun has been. And as you can see, it starts on the date of our last meeting in December, and it goes on through today. So that encompasses about, 4 weeks. And we've had every yellow box is a sunspot or an active region. And you can see we had 2790 and then 2792. I don't know what happened to 2791. I'm at a loss. It must have come and gone so quickly that it didn't even make the list. So we had 2792, and as you can see on December 14th, we had a solar eclipse. I've got a few pictures. Got a few pictures of that. Nothing much, just touching on it because it is something solar. So we rocked on in 2792 and 2793, and then 2792 left, and we had 93, and then we had a couple of spotless days. And these were the last 2 spotless days of 2020. So we ended up with 208 total spotless days for last year, which is about right for where we were in the cycle. It wasn't anything terribly high. And then, of course, we went through the winter solstice, and this was also the day of the Great Conjunction. We had 2794 come on. And what I want to point out is look how long 2794 stayed. It went on 1 week, 2 weeks, 14 days.
Wow. So
it was a great, big, very round, symmetrical sunspot. And it gave us an opportunity to see an effect that I hadn't really studied much, but I'm going to talk a little bit more about it. It's the Wilson effect. So along with 2794, we had 2795 that lasted almost as long, I think 12 days, 13. And then we had the sun and earth at perihelion. And we had a double chromatic mass, coronal mass ejection, excuse me. And then sad to say, on the 4th, we had our first spotless day on the sun. And it's been 5 days, no spots. And what's interesting, I never thought about this before, but the first spotless days of the year are always equal to the spotless current run. So after we get a spot, the spotless days and the current run of spotless days will be different, if that makes any sense.
Yeah.
So you can see, like back on the 19th, we had one spotless day for a total of 207 in the year. Well, on the 4th, we have 1 and 1, 2 and 2, 3 and 3, 4 and 4, and 5 and 5, so on. Interesting little thing there. It doesn't really mean anything. So let's go see what happened here. This is what the solar eclipse looked like from space on the surface of the Earth. You can see it went right across Argentina, which was where a lot of great pictures came from. I think it lasted like 4 minutes of totality. It wasn't very long at all. Maybe it was 3. And an interesting thing about this little picture is that on the right side, you can see the nighttime coming across the Earth. It happens pretty quick. So anyway, that's what the spot of the shadow of the sun on the Earth looks like. It's something that I've seen on Jupiter. When one of the moons transits, you can see the shadow transit across the surface of Jupiter. This is exactly what's happening here. And I'd be curious to see what it looked like from farther away.
Yeah.
All right, so it was a picture taken from Argentina, and this is a great picture. This guy's a wonderful photographer. It was a total solar eclipse of 2020. This guy's last name was Druckmuller, I believe. And this has to be a composite. This has to be a mixture of several different pictures with different settings, because you can see surface features on the moon. So I thought this was a great picture because it shows the magnetic lines of the corona straight up and down at the poles, and then at the equator, it just loops in, or sometimes it spews out. But I like that picture. And also, in the top right, you can see a little comet here, a sun grazer.
Oh, wow.
Maybe this was Comet Erasmus. It got as close as Mercury, at least. It may have gotten even a little closer to the sun than Mercury did. I don't think it made it out on the other side.
Oh.
So here's a close-up of that same picture, and I wanted to point out what you can see if you look is up here you see some prominences that are, it's amazing to see it in the daytime, and the only filter that you actually have is the body of the moon in the way. So here's some more prominences on the other side, and you see all these looping lines of this solar wind. The corona is what it is. Like I said, he had to have done some composite pictures. I don't know this for a fact, but that picture is just so amazing.
It's beautiful. And I'll comment, Eddie, this is similar to exactly what I saw in Casper, Wyoming in 2017.
Exactly. Yes. Did you get any features on the surface of the moon? Or
yeah.
Were you able to get?
Yeah, visually, yeah. Not on camera because I didn't do the HDR like you're talking about, like a high dynamic range composite. But yeah, naked eye, I could easily see the moon's features. And then through Howard's little spotting scope, because Howard Miner, our friend, was there with us. Through Howard's spotting scope, I could actually make out different areas and stuff, which was pretty impressive.
Yeah.
At least maybe my mind's making all that up, but I'm pretty sure I remember seeing that. Yeah.
Yeah, I remember seeing a prominence, and I remember seeing the corona. I don't think that I was able to pick out features on the surface of the moon. I will point out that every instrument that we looked at the sun with that day was a specialized filtered instrument or a specialized telescope built just to look at the sun. So it was all very safe. And we all had the solar eclipse glasses, which, you can put those on in solar film so you can look straight at the sun and it won't hurt your eyes. So let's all remember that there's going to be a solar eclipse that comes right through Texas in 2024. So start planning now because it's about 3 years away now.
Mm-hmm. Very soon. And you'll be able to see an image very similar to that.
Yeah, it's a wonderful thing to see. Okay, so here's that comet Erasmus. I got this as a Soho picture, and it's actually a small video. The comet's going to appear right over here on the right side. You're going to see a lot of speckles and streaks, and just don't pay attention to those. The comet will run right through here. You'll see some coronal mass ejection coming here. This is Mercury, and watch how Mercury makes its way in its orbit across. So let's see if I can start this without going to the next screen. There we go. So there's the comet. And then there goes Mercury across the bottom of the screen. And as you can see, it's getting dimmer and dimmer, that comet. And it goes off screen, but it didn't crash into the sun like some of these sun grazing comets do. So maybe it made it out the other side. I apologize for not looking to see what actually happened to it. But that video you saw took about 2 weeks. So we couldn't see it naked eye from Earth. It was too close to the sun, but the Soho satellite did.
Amazing.
So I want to talk a little bit about not 2794, the big sunspot, but the one that trailed at 2795. It actually had some canyons. We saw this and we call it cracking last month in one of the sunspots. This month they're calling it a canyon because apparently that canyon is as wide as Mars. So it's a pretty big canyon. And you see it here in white light, and you see it down here in the magnetogram. And of course, the magnetogram, this was in the southern hemisphere, so the rotation was from left to right. And this solar cycle, the sunspots in the southern hemisphere are going to be negative leading the positive as far as polarity on the magnetic fields of the sunspots. So here's a picture that was taken by a gentleman named Michel Willemin from Switzerland on the 27th of last month. And this is one of the mountains in Switzerland. And what's interesting is you can see sunspots on it.
Wow.
So note the orientation is not quite the same level as the clouds, but it goes off almost at a 45-degree angle. And I was thinking about that because this is what the sunspots were, and they're not angled, they're following one another quite horizontally across the surface of the sun as it spins. And the only thing I can think of is that the Earth is tilted 27 degrees, so that's almost 30, and I think the sun has a tilt of about 7 degrees, so 37 degrees, that's close to 45. So maybe that's why it was tilted like that. Anyway, that's the two sunspots. There's that 2794 that I said was a big, round, stable sunspot. We're going to look at that a little bit longer. But first, I want to point out that we had a super sun. You've heard of a super moon? Well, we had a super sun on January the 2nd. And here's a couple of pictures that a gentleman, I can't pronounce his name, Khosrow Jafarizadeh. Anyway, he did an amazing job here. I've never seen anybody do this, but there's a difference between the sun when the Earth is furthest away from it at aphelion, and then when the Earth and the sun are closest together. And this happens because the Earth's orbit is not a perfect circle. It's an oval. And so at some points in Earth's orbit, we're closer to the sun than at other times. Now, you might think that this would affect our weather here, and it's just a very minor effect. Most of the weather effects that we feel on Earth are caused by the seasons and the tilting of the Earth.
Very cool, Eddie. So, I didn't know that it was. I didn't know that it was that close. That's neat.
Yeah, the difference is about 147 million kilometers versus 152 million kilometers.
Wow.
So it's, that's pretty good wobble, I guess.
It's a good walk. Yeah.
Yeah. And if the Earth was not tilted, this would determine our weather.
Mm-hmm.
Anyway, so the next thing I want to talk about is the Wilson effect. I'd heard of the Wilson effect, and I decided to do a little bit of research to see what it would take to do the Astronomical League program on sunspots. And here's one of the forms you've got to do, and this is an example that they provide so that you can kind of see how to do it. And down at the bottom, it asks you, does the drawing show the Wilson effect? Made me realize that I had not an exact idea of what the Wilson effect is. There's a little bit more magnified. So does the drawing show the Wilson effect? He says yes, and then he says very much so. But just looking at the drawing doesn't give you an idea of what the Wilson effect is. So here's the Wilson effect. I'm going to play this video. We're going to watch those sunspots go across, and I'm going to talk about what's going on. So here comes the sunspot. You'll notice it's flat, narrow, and as it comes to the surface, it starts to look round. And then as it goes around to the other limb, it starts to get narrow again. Now, it doesn't ever get longer, but it gets thinner. Now, let's think about what that means. In 1769, during solar cycle 2, there was a Scottish astronomer named Alexander Wilson. And he noticed that the shape of the sunspots flattened as they approached the sun's limb due to the solar rotation. And that observation showed two things. One, it showed that the sunspots were features on the surface of the sun, as opposed to being something in front or above the sun, like a planet. We've had the opportunity to see Mercury transit across the surface of the sun. And what we see there is it's just a flat disk that goes across the sun. It doesn't change shape. And that shows that it's not on the sun. But sunspots, they do change shape. And it's all a perspective for us. There it is on the left side, thin. In the middle, it's round. And this sunspot was just perfectly stable for us to see that effect. Now, I want to point out some additional features. And I hope everybody can see the way that it kind of changes shape due to our perspective. So here's the sunspot in the middle, and I've included the Earth here for scale. That's how big it was. And you can see it's kind of narrow. It's also tilted a little bit. Now think about it. Because it's not exactly on the equator, it's a little bit low, it's coming across the bottom of that sphere of the sun. So that tilt makes sense according to where it's at. But here's some graphics that Kat helped me put together. Here on the right is a flat place setting with a round white piece of paper towel. And that we would call this the umbra, which would correspond to this dark spot. And the outside would be the penumbra, which would correspond to this lighter color on the outside. So notice on the flat place setting, the distance from the edge of the umbra to the edge of the penumbra is about the same on both sides. Actually, this is tilted. It's tilted at the same angle that the sunspot is, but it's about the same. Here's a bowl with the same size paper towel in the bottom of it, and it's tilted. Notice the distance from the edge here to here, as opposed to the edge here to here. This is a lot narrower. And that's what we see here. It's very subtle, but this edge to edge is narrower than this edge to edge, which Wilson thought this meant that the sunspot was actually a depression on the surface of the photosphere. So I'm going to compare this to that straight on. Notice the distance is the same. as on the place setting as it is on the bowl. I hope this is clear. I tried to make it as clear as I could, but that's straight on. That would be right in the center of the sun. And then as we go to the other side, everything tilts, and here it is tilted. Not much of a difference on the flat surface. So we know that the sun's not flat, but look at the difference in the bowl that you know has a depression. And you can kind of see here, it's narrower here than it is here. Again, it's subtle, but that's the Wilson effect. It makes people believe that there's a depression. And Will, you might know more about this than I do. As far as I know, we haven't actually ascertained that that's a depression. It's not actually a crater-like feature. Do you know anything about this?
So when I did all this research for the Wilson effect, when I did solar white light like you did, my brain told me it's obviously a depression, but I could be wrong. But my brain tells me that it is a depression, and this is a knee-jerk reaction, kind of like my gut instinct. Because if the sunspot represents an area of higher magnetic activity where material is being brought up, then it would make sense in my tiny human brain that would create an area of less material at the photosphere because it was being brought up. I could be completely wrong, and it could just be an optical illusion. So I would defer to your expertise, since you're more fresh on it than I am. Well,
I believe like you, from what I can see and the application that I can put with this little bowl experiment, it looks like a depression to me. I mean, this compared to that,
yeah,
something's happening there with the edges. So yeah, to me, it would seem that there is some depression there. But in doing my research, I also came across some other thinking and research that indicated that that's just an optical illusion. So I'm afraid that I don't have the ultimate end-all answer. And I would encourage anybody that's interested to please look into it. And if nothing else, go look at the sun and see if you can see this effect for yourself. Because like Will said, when you see it, that's exactly what it looks like. It looks like a depression.
Yeah. Yeah. And it was something that I noticed, Eddie, before I got to that part of the award. And I was like, why are these things? They look like they've been scooped out at the edge.
Wow.
And then, because I didn't know what Wilson effect was when I started the award. That's not the point. You don't have to know everything about these Astronomical League awards before you start them. That's the point, is you learn things like Eddie did. Eddie was like, what in the world is this effect? And so he went and looked it up. And, but sometimes when you go digging for answers, you find more questions. And that's the beauty of astronomy, in my opinion, is like we were talking earlier, you never learn it all. It's interesting stuff, Eddie.
Yeah. So
and a beautiful, like Sharon said, excellent demonstration on this. I've never seen it done this way. And the cool thing about what you've done here is we did it online. So everybody gets to watch this forever. It's not like we just did this at an astronomy meeting and then it goes away. Right. So yeah. And when you go fast like that, you can definitely see what's happening there. Very cool.
Wilson effect. So when you do your solar observation program, and it asks you, was the Wilson effect shown on your drawing? You can say, yes, absolutely it was.
Very much so.
Very much so.
Or not at all. You didn't see it.
Yeah. So the last thing I have here, or close to the last thing, is the videos that I like to show of the last month on the surface of the sun. This is in the 1700 wavelength, and this is taken by the SDO satellite.
Mm-hmm.
And those are the sunspots. And as you can see, the sun was pretty quiet. Not much to see there, not very fantastic. There's going to be another view. I want you to pay attention to this because there's going to be a couple of coronal mass ejections that happen. I'm going to go ahead and tell you they're in the southern hemisphere. So keep an eye out. They were pretty phenomenal. If you don't catch it, I'll play this a couple of times and then I've got a really good close-up. That's not it. This is not even the active regions yet. This is not where the sunspots were.
Mm.
Here's 2794 right here, and here's 2795. Yeah, we missed it. It happens.
By on us, didn't it?
Yeah. Let's see if I can play it again. It happens right in this area.
And on the time,
I've watched it. Oh, I'm sorry. It happens in this area. Yeah, there it was. I saw it. I'm going to show you. Let's look at it in this wavelength, which is a little bit different, but it shows you more of the corona, and you can see some really good magnetic flux lines here on these active regions. And a coronal hole that was responsible for, and this one as well was responsible for a couple of aurora, a lot of aurora here on Earth.
Beautiful.
Last month, yeah. So here's the one where we're going to see, because this is only a couple of days, and I want you to pay attention to this horseshoe area. The first one's going to come off this side, and it's just it's going to bubble there, and then it's going to blast off, and then you're going to a second later, you'll see another one come over from this side. So let's see if we can do this. It's happening a little bit slower. There's it's starting to percolate a little bit. It's starting to jump, and
whoa!
Here it comes. Here it comes. Oh man, did I miss it?
I don't know. There was a little shift in there that I saw at some point.
Yeah. You know what? This is not the best wavelength. Like I said, it depends on what wavelength you look at.
Yeah.
There was one happened right here.
And
the other one's going to happen.
There you go.
Yeah.
I think that was.
So there's the second one. So let's look at it. Yeah, let's look at it. This is the wavelength where you're going to see it. If you don't see it here, man, I apologize, but this is the one that initially caught my attention. But let's look here.
So that was a filament right there, right, Eddie?
Yeah.
See it right there, and then it kind of breaks off.
Did you see it?
Yeah.
That was the first one, and then like a couple of days later, there was the second one. Mm-hmm. And like I said, there was some concern because one right after the other, and the first one was traveling slower than the second one, if you can believe that. So they were worried. Scientists were worried that the second one would catch up to the first one, and it would just be a bigger one when it hit Earth. Fortunately, it didn't it didn't cause us any problems. It didn't hit us straight on. I'm gonna try to play it again.
Instant replay.
Yeah. So look down here. This is nice. But look up here too. See, yeah. Here it comes. There it is. That's the big one.
Yeah, you see it lift off there.
And there's the second one. So a couple of coronal mass ejections. Interesting stuff. And again, we're just coming out of solar minimum, but it's exciting stuff happening on the surface of the sun. And that's it. Thanks, Will.
Yeah, absolutely. I thank you, Eddie. Amazing stuff. I mean, the sun it's been really boring the last couple of years, unfortunately. And we do solar outreach as a club, fortunately. But the last couple of years, when we've been going out and doing, daytime on a Saturday at the Beaumont Children's Museum or Valero Kids Fest or wherever we're at, we're like, hey, kids, here's an image of the featureless sun. Enjoy.
Yeah, look at this orange spot. That's what you're going to see.
Like, that's not the sun, that's an orange. Like, yeah. Okay. But it's hard because even for us, we're just like, wow, this is it right now, And I mean, that's the game that we play with astronomy, is that there are, bad weather days, there are great weather days, there are sunspotless days, but man, when we get into the really active times, that it's just like Eddie said, there's so many features that you'll just get lost in it, and it's just absolutely mind numbing. But thank you, Eddie. That was a great way to explain the Wilson effect. And there's so many of these little little tiny details in all this that, you know, and maybe that's the first time you've even heard about solar observing. That's okay. As you go down the road of learning astronomy and doing this on the regular, you're going to hear these terms and you may not understand it even now, but over time, the seed will have been planted and you'll start to, that knowledge base will grow. And it just takes hearing stuff a bunch of times. Because trust me, I've had to hear it all a couple hundred times before I'm like, what does that even mean? What are we talking about here? Plage or facula or filament or prominence or what? You know, so, but get out and observe the sun. Cause like Eddie said, it's so choice. It's so good. Yeah. Okay. So, I'll go ahead and put this, well, as we're winding down here, I wanted to show this really quick. There we go. So, a friend of mine that I met on the internet, his name's Hunter. He does these live streams where he reads stories. It's almost like a modern day radio hour where he gets on there and he reads these stories. And one of them that he was reading the night that I was watching had this story about a star in it. And and the story just intrigued me. And so I wanted to pass along the cool bits about the story. So this is the constellation that everybody knows, Cassiopeia. If you don't know Cassiopeia, you've heard the name. If you don't know, you've probably seen it in the sky. You just might not really realize that you've seen it in the sky. But it's up there, and it's basically up a lot because it's almost circumpolar. It's not quite, but it's pretty close. It's a very famous constellation, and there's a star in it called Gamma Cassiopeia. It's the one right. If you see that sort of upside down W, I guess, or in this case, it'd be a sideways M. The middle star there, right next to the word Cassiopeia, because I don't know if my cursor is going to show. It's not going to show. But that middle star, anyway, is called Billy Jackson. I don't know if y'all really knew that, but according to this short story right here, which Hunter Ackerman read on his live stream, that was super awesome. There's a story by a very famous author, O. Henry. I mean, most of us have probably had to do a book report on this guy at some point, right? And a story called The Skylight Room, which is a beautiful name for a story, by the way. And I'm not going to go through the whole story about what it was and all this stuff, but there's the Wikipedia page, and you can kind of pull some information out of it as you need to. But in the story, it goes into great detail about which star it is in Cassiopeia. The storyteller was very, very specific about that. And it's the woman in the story calls the star Billy Jackson. I don't think it ever really goes into why. It was just a name that this person put on this star, and boom, there it was. And she tells people about Billy Jackson, and did you know Billy Jackson's a star? And someone scoffs at her and says, no, that's Gamma Cassiopeia. You know, that's not a Billy Jackson at all. And I was listening to the story, and I'm like, which star is that? I've got to look this up, because this is too cool that, William Sidney Potter, or O. Henry, however you want to call him, put this in a story back in 1906. This was, or I think it was even maybe a little bit earlier than that, when he first published The Skylight Room. So don't get mad at me if I got the history wrong. Needless to say, this was done in the early 1900s. This story was written, and it's a super fascinating story. So if you ever get the chance, read The Skylight Room. But what's cool is it used this middle star in Cassiopeia. And I thought it would be interesting to tell y'all what the real name of that star is. It has a couple of different names, but the one that's actually recognized by the International Astronomical Union, the IAU, is Navi. And this is the only star. Now, William or O. Henry, William Sidney Potter, had no idea this star was called Navi, because it wasn't named Navi when he wrote this story. This star was renamed Navi, or however you want to say it, by Gus Grissom, the Apollo 1 astronaut who actually perished on Apollo 1. It's one of the astronauts there. He used the star, I believe, as a navigational star. Yeah, it's a navigational reference point in space. So he renamed it after himself with his middle name backwards, which his middle name is Virgil Ivan Grissom. Okay, so he named it Navi after himself backwards. Now, this is something you can't do in astronomy. You don't get to rename things for yourself and then have it recognized throughout the international community of astronomers. But this is exactly what happened, because when Gus Grissom, Ed White, and Chaffee, I forget, is it Robert or Roger Chaffee? I'm so sorry, I can't remember his names. The three astronauts that died on the pad on Apollo 1, they died in a fire in 1967. This star was actually renamed, and there you can see it was called, I can't pronounce that, Eddie, TSIH. Can you want to take a stab at that?
Yeah, I'm not. Oh, yeah, we'll say C.
C. Okay.
C.
Yeah, C. Which I like Navi way better because I can pronounce that readily, and it's the only star named after a modern day person that's recognized by the AI. I mean, you can name a star.
Fascinating.
Yeah, you can name a star after, if you want to call Betelgeuse, Eddie Trevino, you can. But no one's gonna also call it that.
Yeah, this one caught on.
Yeah, this one caught on, and it got recognized. And I thought that it was so fascinating that this story that was written in late 1800s, early 1900s, had this parallel with an actual astronomical thing. And that brings that story into so much more relevance. I think I can't wait to hear the story again, because the whole time I was listening to it while he was reading it, I was like, man, this is super cool. What star is this? And then I went on this personal journey while he was reading it to try to figure out which one it was. And I was like, oh, this is Navi. Like, this is crazy. And I remember that being named after Gus Grissom and all this. And look, one day this thing will explode as a supernova, which is super cool. It's 15 times more massive than the sun. So
wow.
That's a pretty cool thing. It'd be really nice to get to see that in our lifetimes, although that's very, very, very unlikely. It hasn't even started changing color yet or whatever, but it is a big star, and it's 610 light years away. So there you go. It's a pretty cool little story. And if you get the chance, again, the story is called The Skylight Room. I'll bring that back up. There you go. And you can kind of get, kind of sit by the fire like Hunter did and read a story with your cat or your dog or your family, and read them The Skylight Room. Because it was a really cool, like his whole vibe of his broadcast is amazing. He does an excellent job. And it's such a cool story for him to randomly pick, or maybe he did it on purpose. I don't know, but super cool. And so he did a great job with that. And I just thought I would throw that at you guys as we're kind of closing it out here.
You know what's cool about that, Will, is that if you looked up at Cassiopeia, you've seen that star, and I never gave it much more attention than any of the other stars in the constellation. I don't think I've ever actually put my telescope on it, but it's nice to have a tale like that. Somebody wrote a story about that star, which means they took time to look at that star and said, I'm going to write a story that has the star in it. And then this Navi, that hits close to home. That's happened in our lifetime, in my lifetime.
That's right. An American storyteller, not hundreds, but 70 years, an entire lifetime before this star was renamed after a tragic event. He had told the story about it. It's really cool. So the storyteller, do you mean who wrote it, Sharon, or do you mean the storyteller's perspective? Because I believe it's from a young woman or an older woman's perspective, and she's the one that's in the Skylight Room, and it's kind of told from her perspective. Again, don't let me butcher it for you. Don't let me ruin it either. Go out and read. It's not a long story. I mean, it can be read in maybe 5 minutes or 10 minutes or however long. Hunter read it out loud on his broadcast, and I mean, did it fantastically. The guy should definitely be reading audiobooks for a living, because he's got a great narrator voice. But the way he combined it and the way it worked, it was just an awesome thing. So definitely go. Oh, okay. So his name's Hunter Ackerman, and I don't have a link for that, but I'll turn Eddie loose on one of these next topics, and I'll get y'all his YouTube page. And I know he's in a band in LA. It's Hunter and the Dirty Jacks, I believe is the name of his band. They're a bluegrass band, which is amazing.
Cool.
Yeah, and they're really good too. And he does Hunter's Acoustic Cabin on YouTube. I believe, hope I'm not butchering these, but on those, he does like acoustic videos of him playing guitar, and he does all the instrumentation and then sings or plays harmonica with himself. Super cool stuff. Super cool stuff. But I'll definitely get that link for y'all on one of these next topics, because as we're closing out here, I want to get through some of these before we have to go. But SLS is on the way, y'all. I know it's kind of hard to tell what's going on in this image, but if you look right here, this orange tank at the top, this is Artemis 1. This isn't like the analog for Artemis 1 or, a pre-Artemis 1. No, this is Artemis 1. And they just did the green run, which means they filled the core stage of Artemis 1 with the fuel. They filled both tanks up, and then they all ran away to see, to make or something. But they filled the tanks full, and they let them stay pressurized. I forget for how long, but it worked. It vented properly. Everything worked. So now they go to the next step, which is the green run hot fire test, where they fill her back up with the cryo and the fuel, and they turn her on for, I think it's 8 minutes. So they're going to burn all 4 RS-25 engines for 8 minutes. And what I want to do here, I want to share. Trying to talk and do buttons is hard.
Well, I wish I could help you with that.
I know, right?
So that picture you showed, that was it's hard to get a perspective. Do you think that basically is a huge tank?
Yeah, it is.
Yeah,
this orange thing is the tank. Think back to the the shuttle days. Yeah, this is going to be essentially if you married the Apollo rockets and the shuttle together, and you got a hybrid vehicle. That's what SLS is. Tried and true. It looks exactly right. It's an Apollo rocket with 2 solid rocket boosters on the side. Yeah. There's the RS-25 engines, which, by the way, I think 3 of those are legacy engines that NASA has kept since the shuttle era. 3 of those engines have flown on multiple shuttle missions. In fact, I know a guy who has flown on one of those engines on 2 occasions, I think.
Wow.
Astronaut Don, what's Don's last name? Pettit. Don Pettit. Met him multiple times. Got to hang out with him and talk with him for a while. He's a really cool dude. But yeah, so they filled this thing up, like I said, and ran away to make sure it didn't rupture or anything else weird. You can see the venting is doing exactly what it's supposed to do. That fire is completely normal.
Yeah.
I've actually stood next to this test stand, and this is where they tested the Mercury rockets, the Apollo rockets, the you name it. They tested the engines for all those things here. And they built, I think it's 1.5 million tons of extra metal structure to hold the SLS down, because it's going to be the most powerful rocket ever built by humanity once it's complete. So they've got a big apparatus to hold this monster down while it's full throttle trying to take off to space. And so they're going to do that green run, I think, at the end of the month here. And then I think Artemis 1 flies in October, which is going to be an unmanned mission. I'm not exactly sure. I think it might be the one where they go around the back of the moon and then come back. Don't quote me on that because I'm not exactly sure, but it's going to be great. I can't wait. And I hope y'all are excited about this too, because I'm very excited about NASA rockets being launched again.
Yeah. I'm having trouble getting my size perspective. I mean, a couple of these videos, they show handrails on what would be catwalks, and those handrails generally come up about hip, a little bit higher than waist high.
Yeah.
And those rocket engines are massive. And since 3 of them are legacy, that's a testament to the people that maintain them. mean, think
That's
about
right. They had them in bags apparently in warehouses. I'm kidding you not. I talked to the Aerojet Rocketdyne guys about this. When I actually got to stand next to all these engines right here, I got to see them with my eyes, and then I got to go see the ones on Artemis 2 and 3. I got to stand next to and take a picture with one of these engines that's going to be used on the first manned mission back to the moon, Artemis 3, which is amazing. I stood next to the engine, and like Eddie said, they are way taller than you. I think maybe the engine is 14 feet high or 19 feet high, just the engine. So good luck, like standing taller than that, and but it's huge, guys. These things are absolutely massive, and so I can't wait for that. You can kind of get a sense of scale there, but like Eddie said, it doesn't really show the full story.
So, Will, when you show that building that's got the structure in it, you can't really see the bottom of it. Do you know, is that tank go all the way to the ground level, or does it end somewhere?
The tank,
the first floor? The orange part.
Oh, So, I wish I had a picture of the SLS now to show you. Most of that core stage. I wish I could find a wider shot. I think there was a wider shot here at the beginning somewhere. The
right
whole
there.
Core stage is tank, fuel and oxidizer, and then the rocket engine part that you saw was kind of down in that area right there.
Okay.
So if I go back here, you can kind of see it's in this general area. The rest of this is water suppression. So you can see these big troughs. There's holes, hundreds of holes. You can see the water kind of being sprayed out of some of them. They're not all on. They're everywhere so that this thing doesn't destroy. It's sheet steel too.
Wow.
Absolutely. You can see the water kind of running down it here. This stuff is insanely strong. And this is the one they were doing the shuttle testing stuff on over here. And so now that you see they got this other side for SLS. So pretty cool stuff. And that's coming up. And another thing that's coming up, did my screen change? Or no, I don't think it did. Oh, and you know what? I probably messed it up. I'm going to have to screen share it again. Another thing that's coming up, y'all, is the James Webb Space Telescope. And I know I used to do these all the time where I used to do a James Webb Space update, and it was always the same thing. It's broke, and they're not launching it yet. Well, it's not broke anymore, and they are launching it this year. And I think this goes in October as well. But there's this cool, on the NASA website here, if you just search James Webb Space Telescope and go to the NASA link, they have all these little games and stuff that you can play with your kids and stuff, and they can build their own satellites and understand and learn about how different telescopes in space work and what wavelengths of light they can capture and all kinds of cool stuff. Just a neat little game. And then you can print out these little paper models and put those together.
That would be cool.
Yeah, and there's some artwork done that's just crazy good. It's the mirror segment here with a bunch of human eyes looking out. It's amazing stuff. And there's a VR experience. If you're into the VR stuff that's popular these days, you can check that out. But that is coming October. So be ready for that. Start telling your friends and everybody you know and care about that October 2021 from French Guiana down in South America, they're going to launch the James Webb Space Telescope, and I can guarantee y'all that everything is going to change when we get to that point. Let's see. One more thing I want to share. Yeah, go ahead.
It'll take some months between launch and where it gets to where it needs to be. One of the Lagrange points.
That's right.
So it's not going to be an immediate launch yesterday. We're getting pictures today. It's going to be a little bit of time waiting and hoping that nothing goes wrong between launch and final destination.
That's right. And
suspense.
And hopefully you didn't jinx it, Eddie, because I think out now everyone would blame you.
No.
Not at all. No. I wanted to throw this up. This is Hunter's acoustic cabin. This guy is the guy who told the story, or read the story for us. He doesn't do live casts. He does love casts, ladies and gentlemen. The guy is just a really well-spoken, intelligent guy. He's a great musician. So give Hunter's acoustic cabin a follow if you're into bluegrass style music. He does all kinds of styles too. And I guarantee you that Hunter and I are going to work on a song together in the near future for sure. And there's one more thing that we'll talk about as we're closing it out here. And I know I have it somewhere. Weird. Maybe I have to undo this. There we go. I wanted to just quickly show the newsletter that we have as a club as we're closing out and saying our goodbyes. Howard Miner does these for us. Fantastic job. It's always a pleasure to read through these. Every month I get it, I'm always excited to read what's been going on and what Howard's put together for us. I got a president article in there. Brenda's got, it's usually minutes, but since we're not meeting anymore, she does news, which is fantastic. And then what's cool is Howard put in a bunch of pictures of the conjunction in here, and this is how we'll kind of close it out tonight. But the first one right here is a picture that Howard got, Mr. Howard Miner himself. He put all the information there for you. Shows Iapetus and Titan and Callisto, Ganymede, Europa, all the moons of Jupiter and Saturn themselves. Super cool stuff. I'm so glad he got a chance to see that. And Chuck, our vice president and good friend, Chuck, got a nice shot of the conjunction. And of course, this doesn't know justice, guys. It's it's so minuscule in this little window here with the PDF, but I think y'all can get the idea that it's right there, so close. Beautiful shot from Chuck. Justin McCullum got a nice little shot. Put a lot of detail into this one. Put a lot of information on there, which is always really cool. And that's how I remember seeing it. I remember seeing that little star right there, right next to the moon. So that was really cool. And here's one from Mr. Eddie Trevino himself of the moon, Jupiter, Saturn, and then Jupiter down below. And that's a really cool image, Eddie. I remember that night exactly. I was on the side of the highway because clouds were covering Southeast Texas. So I drove towards Houston, and I saw the clouds break, got out and set up and got a shot similar to what you got, which is pretty awesome, man. I'm assuming you didn't have to travel anywhere though to get that.
No, that was from the back balcony. All my observations have happened looking west out off that balcony this past month.
It's a famous balcony, at this point. I did a little superimposed image on 12/17 because they were finally close enough together to fit inside the moon from our perspective. So that's what I did there. I put Saturn and Jupiter over the top of an image of the moon that I took at the same zoom, same focal length, same everything. And it worked out really well. And then I think there was another one here. Yeah, Spencer Pratt, our good friend who's in the chat hanging out with us, got Saturn and Jupiter, which is amazing. I think he did it through his iPhone, if I'm not mistaken. I think he did.
Go on up to the picture.
EOS 5D. Yeah. 5D Mark IV. And there's all his EXIF data. If you didn't know what EXIF meant, EXIF, that's like, what are your settings, dude? If you want to sound smart, just say, what was your EXIF on that? little tip from the dude on that one. And that's where we'll close it. What I want to do, though, is get to a few comments as we're closing out. And Eddie, did you have any parting words of wisdom before we take off here? I'll go through some of these comments.
I'm looking forward to the next month. I'm hoping to put some actual eyes through a telescope on the sun this month. And, if things start rolling, I'm going to start that solar observation program, that white light one. And if I have the energy, I'll try to do the hydrogen alpha one at the same time. I mean, I'll be out there. So let's keep our fingers crossed and hope for good weather and for some good activity on the sun.
Yeah, and that's a good idea, Eddie, to kind of do them concurrently. If you got, if it's clear, you can do both on the same day. There's no rule that says you can't at all. And you just have to, I guess, what are you going to mount? 2 different mounts? Are you going to have them both on the same mount, or how are you going to do it? What's your plans?
I'm going to look. I have one mount here with me, so I'll mount one telescope, work however long it takes me. If it takes me an hour and the sun's still in a good location, then I'll just quickly swap the scopes out. It's about a 5-minute job. Yeah,
and then you're, because these awards take a little while to do. I think the white light is like you have to do it over 2 cycles, which is 2 months ultimately. And you'll end up doing more because there's never that many clear days in 2 months. At least there wasn't for me.
And there's never, hopefully there'll be, there's certain things you have to look at. There's certain things you have to see and sketch. And if those don't occur within the 2-month period, you got to stretch it out longer.
Mm-hmm.
So,
yeah. And then, that just adds more experience under your belt. Because I find if you do one of those programs really fast, you learn things. But I feel like if you chew on your experiences more in your head in between, the same program, it does make more sense over time because you have more time to kind of grasp it. These things aren't readily available concepts. Our tiny human brains were not designed or set up or didn't evolve to comprehend any of this stuff. That's why the Wilson effect, we're all like, what? Is that really happening? Like we're seeing these coronal mass ejections. This is just the way the universe works. And we're all like, what is going on here? And that's just the age of discovery, and that's where we're at. But I love it, man. I mean, every time I learn something new, it broadens your horizons as an astronomer and as a human being, ultimately. So, if we don't have any other pressing issues, we'll call it good there. Again, we meet on the second Friday of every month, unless there's a weird schedule shift. I know tonight the Houston Astronomical Society, our sister club, just 100 miles west of us, met tonight. And they had to change their meeting, or we would have changed ours so that they could come to ours. We can go to theirs. But we're having an astronomy meeting at the same time. There's nothing wrong with that. A lot of astronomy going on. It's a great thing, even despite this time. And but we will be back next month around the second Friday, or if not the second Friday of February, right here on YouTube and Facebook. And we're gonna, this year we're gonna start looking towards doing in-person meetings again. If we can get through the cases have to go way down, the vaccine's going to be widely distributed, and the school district where we meet has to say, hey, come on back, and then we'll come on back. And then, I don't know what we're going to do. We may try to still do these online meetings, but typically we don't broadcast our in-person meetings. Maybe we'll make that change in 2021. Maybe that's how the whole thing will impact our club. Who knows? But I want to thank all of y'all who have hung out with us all the way till the end here on a Friday night. You guys are awesome. Thank y'all for the shares, the likes, the comments. Y'all are awesome. I mean, we had viewers from all over the world tonight. That's something that doesn't normally happen at our in-person meetings. We very rarely get viewers from the Netherlands inside the planetarium in Beaumont. So thank y'all for coming and hanging out. We had Ireland tonight. We had Central America, South America.
Wow.
All of it is amazing. So it's always fun to go back and read the comments.
Yeah, they see the same stars we do, Will.
That's right. We're all under the same sky, like that Disney song from back in my childhood. Or maybe it was a Disney song. I can't remember. Was it Feifel? I can't remember. We're on those sad Disney. So Eddie and I talked about this the other day. I don't watch Disney movies anymore because I don't want to cry watching a movie. I got time for that. And Eddie's like, you should watch Soul. And I'm like, I think it's going to be sad. And Eddie's like, yeah, you don't want to watch that. Okay.
Yeah. It's always, they make you sad, but then they make you happy at the end. So it runs you through the whole emotional cycle. So usually they're good endings.
I hate emotions. They're horrible, horrible headaches that hit you. But thank you, Howard, for joining us, man. I know you had some stuff going on today, and we appreciate you hanging out with us tonight. And Otter, thanks for hanging out with us. We appreciate you. And Nathan Price, a friend from Houston, says, thank you for organizing this. It's great that the Golden Triangle has a Golden Astronomy group. That'd be a cool name for it.
Yeah.
I can't wait to attend in-person meetings sometime. We can't wait to have you, Nathan. That's going to be awesome. Yeah. Nathan's somebody I met online and did an interview with a while back. And it's going to be great to meet these people in person because it's almost going to be like, we've all just been hanging out despite the virus, because we have. Eddie and I right now are face-to-face. We're hanging out. We're chit-chatting. We're sharing ideas. We're sharing knowledge. And we're sharing that with all of y'all. And so, that this thing hasn't really stopped humanity all that much. We learn to adapt and overcome very well. So That's the way it is. And look, we even had Louisiana in the house, all the way from Louisiana, which is just like 5 miles that direction for me. But good to have you, Louisiana. We always appreciate our Louisiana amateur astronomers here. But that's all I have. I think I can then say adjourn the meeting, because I adjourned us right at the beginning, which was really dumb. But now I'll use that term properly, you know, and say that we are adjourned. Again, last minute thoughts, Eddie. You got anything? You just clear skies for it.
Thanks for doing this, Will. You do a great job bringing people together and making people enthusiastic about our hobby, which we've already got the enthusiasm. We're just trying to share it. And you do a wonderful job of getting the word out. Thank you.
Well, thank you.
Thanks for everyone for joining us. It's nice to see people that I know. And like Will says, I look forward to meeting some of these other people that I've seen the names, but I haven't met you yet.
That's why name tags are going to be absolutely important when we all start meeting again. But Eddie, you do a great job at this too. You know, your solar reports are some of the best I've seen, to be honest with you. And
thank you, Will.
Yeah, they're much appreciated on these live shows. Otherwise, it would just be me yapping endlessly about nothing. Who knows? So you're very much appreciated by me as well. And Eddie's one of my best friends in the world, and astronomy as well. But we do a lot of star parties together. We observe together. We share objects like, hey, come look at this galaxy, you know, stuff like that. Like, hey, I'm going to get hot chocolate. Let's go. So it's everybody's like abandons their scopes and we all go get hot chocolate and come back later and stuff. So it's good times. And I encourage all of y'all to get out, look up, you know, when the skies are clear, or even when they're not that clear, you can still do a little bit of observing. And when COVID is over, get out with your friends, get out and with a local astronomy club and do this stuff, man. It will change your life. You'll change someone else's life in the process. You're going to learn so much. It's going to give you a broad perspective of how the world works. And I think that's important, especially right now. And so, we'll leave it with that. But Spencer, thanks for hanging out with us. Dustin, good to see you. Good to see you, Dustin, as always. We will be back next month on the Astronomical Society of Southeast Texas. Until then, again, clear skies, y'all, and we'll say goodbye to Kat as we're waving goodbye, and we'll see y'all all right here next month for another Astronomical Society of Southeast Texas meeting. Thank y'all for joining us.
Peace out, guys.